Okay, so my function's x cubed plus 6x minus 1. I'm asked to find f inverse prime of negative 8. Okay, so the idea here is we can find the derivative of the inverse without finding the inverse. So here's your theorem over here, or a summary of it. F inverse prime. Okay, let's start with this one. So there's a point for f of a equal to b, or in other words, this point is on f of x, a comma b. And if you remember inverse functions, that means that point, if f has an inverse, then the point b comma a is on f inverse. Okay, so we can find f inverse prime by just evaluating f prime, so just dealing with the function. Okay, I know that's kind of confusing, so let's take a look at what that looks like. If I want to find f inverse prime of negative 8, that has to be equal to 1 over f prime of what? Well, it's the x value that goes with this y value. Okay, so if I'm organizing myself over here, that means on f, this has to be an output on f since it's an input for f inverse. So there's some input on f that gives me that output. And over here, this output on f is the input on f inverse, and the input on f inverse would yield or output this x value. Right? In other words, we're just flipping our domain and range. Okay, so I'll just give him a name right now because I'm not sure what it is. But that's the idea. If I can find the x coordinate that goes with this y coordinate on f, then I can evaluate the derivative of the inverse function by doing the reciprocal and plugging it into the function, the derivative of the function. All right. So we need two things here. We need f prime. That's easy. And then we need to figure out what this x value is. So I'm going to say, again, this is the idea. We kind of concentrate on f. So I take my output on f and figure out what the input is. And we do that algebraically by setting my function equal to negative 8. And then here's the problem with this one. I can't solve that, or I can't solve it easily algebraically because it's a cubic. We don't solve a lot of those. So what I would do, I'd have to cheat a little bit. I'll go to my graph and graph x cubed plus 6x plus 7 and see where it equals 0. And that's right here at negative 1. So most of these should be solved. When you do these problems, most of these should be solvable. This would be the approach for all of these. In this case, this one's not so solvable, so we have to rely on a graph. And I get the value of negative 1. And f prime of negative 1 then should be 3 times negative 1 squared plus 6, which is 9. And I can replace this. I know that's negative 1 now. And f prime of negative 1 we just decided was 9, so I end up with my slope. Okay, so I hope that helps. That's kind of the approach for all of those. I know it's a little confusing, but the overall idea is you're going to find the derivative of the inverse function by using this theorem, and then eventually finding the derivative of the other value that goes with that value, right? That's a point on both curves.